Hi, and welcome to the first importing data in our course. Imagine this situation. A colleague of yours is still doing his or her analyses in Excel and finally decided to transition to R. He or she needs an easy way to convert the Excel spreadsheets into R data frames, but he or she can't seem to find the tools to do so. Well, getting to know these tools is exactly what we'll do here. In this two-part course, we will focus on 5 types of data. Data from flat files, data from Excel, data from databases, data from the web, and finally data from other statistical software like SS, SPSS, and Stata. You'll learn to convert each data format, one after the other, into an R data frame, ready to do some fancy analyses. Let's start off with flat files. Flat files are typically simple text files that display data as tables. Have a look at this example, states.csv, a flat file where CSV stands for comma separated values. The data lists basic information on some US states. The first line here gives the names of the different columns or fields. After that, each line is a record, and the fields are separated by a comma, hence the extension CSV. For example, there's a state Hawaii with the capital Honolulu and a total population of 1.42 million. What would this data look like in R? Well, actually, the structure nicely corresponds to a data frame that ideally looks like this. The rows in the data frame correspond to the records, and the columns of the data frame correspond to the fields. The field names are used to name the columns of the data frame. But how to go from this CSV to this data frame? We're in luck, because the standard distribution of R provides functionality to import these flat files into R as a data frame. These functions belong to the utils package that is loaded by default when you start R. More specifically, we'll need the read.csv function as follows. The first argument of read.csv is the path to the file you want to import in R. If the file is in your current working directory, simply passing the file name as a character string works. If your file is located somewhere else, things get tricky. Depending on the platform you're working on, Linux, Microsoft, Mac, whatever, file paths are specified differently. To build a path to a file in a platform-independent way, you can use the file.path function. Suppose our states.csv file is located in the datasets folder of the home directory. You can use file.path like this. Because I'm working on a Mac, this is the resulting path. I can now use this path inside read.csv to point to the correct file, like this. The second argument, strings as factors, is pretty important. Say we have columns that are strings. We can choose to import these columns as actual strings or as factors, which R uses to store categorical variables. By default, the strings as factors argument is true, so it would convert strings into factors. In our case, however, the state and capital names shouldn't be categorical variables, so we set strings as factors to false. If we run this call now, we can see that we get a data frame with 5 observations and 4 variables. This corresponds nicely to the CSV file we started with. If we print out the structure of this data frame with str, we see that indeed the 2 first columns are strings and not factors, exactly like we wanted it. Alright, that's enough to get you started for now. Time to give importing data a first try in the exercises. In the previous video, you learned about read.csv, which is an R function that specifically exists for importing CSV data. However, flat file data doesn't come as comma-separated values alone. Another common format of flat file data is the tab delimited file, like this states.txt, with the same data as before. To import it, we'll need read.delim this time. As usual, you simply specify the path to the file, and also that we want to import strings as strings, and not as vectors. Works like a charm. If your data comes in this typical comma-separated or tab delimited format, your life is easy and importing the data is a walk in the park. If it's not, you'll have to do some more customization work. Say we have the same states data again, but this time the values are separated by a forward slash instead of commas or tabs in the file states2.txt. How to go about this? Read.csv and read.delim won't do you much good in this case. Here you'll want to use read.table. It's the main importing function in the utils package, allowing you to read in any file in table format and create a data frame from it. The number of arguments you can specify for this function is huge, so I won't go through each and every one of these arguments. Instead, let's have a look at the read.table call that imports states2.txt and try to understand what happens. As usual, the first argument is the path to the file you want to import. The header argument is something that we haven't seen before. If you set this to true, you tell R that the first row of the text file contains the variable names, which is the case here. Read.table sets this argument to false by default, which would mean that the first row is always read as an observation, even if it's a row of variable names. Next, sep is the argument that specifies how fields in a record are separated. For our file here, the field separator is a forward slash, like this. Finally, there's again the strings as vectors argument, which we set to false again because we want to import strings as strings. The result looks just as we'd want. Nice. Apart from the arguments we discussed here, there are also ways to specify column names and column types, among others. Get some practice on them in the exercises. There's something I haven't told you yet. When I said that read.table was util's main importing function, I was serious. Actually, read.csv and read.delim, the functions to import comma-separated values and tab-delimited files, are so-called wrapper functions around read.table. They call read.table behind the scenes, but with different default arguments to match the specific formats. For read.csv, the default for header is true, and for sep is a comma, so you don't have to manually specify these anymore. This means that this read.table call to import the CSV version of states is exactly the same as this read.csv call, shorter and easier to read if you ask me. Likewise, read.delim sets the header and sep argument among some others. This call to import the tab-delimited version of states is exactly the same as this read.delim call. If you have a look at the documentation of read.table, you'll see that there are two more functions in there that we haven't discussed yet, read.csv2 and read.delim2. These functions exist to deal with regional differences in representing numbers. Have a look at this CSV file, statesi.csv, typical for the US and Great Britain, and its counterpart statesnay.csv. You'll notice that statesnay uses commas for decimal points, as opposed to the dot for statesi.csv. This means that they can't use the comma as the field delimiter anymore. They need a semicolon. That's why the read.csv2 and read.delim2 functions exist. Can you spot the difference in default arguments again? Let's try to import the statesnay.csv file with the basic read.csv function. R gives a result, but it clearly is not the result we want. It's a dataset with 5 observations but with a single variable. If you try again with read.csv2, it works perfectly fine this time. These were just some side notes to wrap up on this chapter. By now you know how to import comma-separated, tab-delimited and even more exotic data formats. But there's much more to learn. I hope to see you in the next chapter to learn about the powerful read.r and DataTable packages.